Tracing E and M. Today we're looking at 2 point charges as we move along the y-axis, finding the E field vector equation for that, and then doing an expansion. So to plot this out, we got 2 point charges on the x-axis, a distance of d, and then our point charge somewhere along the y-axis, and then our E field will move away from our positive charge to our negative charge. So start out in this direction as y is close to 0. And then again, r equals y, r prime equals r d I hat, and our equation for a E field vector is our charge, or magnitude, well, E field vector is our charge over the magnitude of our distance squared in the direction. And so plugging all of that in, we can, and then doing the actual math, we can bring out our vector value, and then we get a nice little equation that's our E field is a function of our distance from the x-axis for the points and our y values. And so then we can do our Taylor series expansion when y is much, much greater than our distance along the x-axis, and we'll do it for 4 terms. Whatever point we choose, it will be constant at that point. We can pull all of those out because we just want to look at our y and d values as a function for our E vector. And then we can pull out another y, so we can actually just look at that ratio. And then do our expansion, 1, 2, 3, 4, all 4 terms. Then looking back at this, we can put those back into our equation. This is our E field vector in the x direction. We can do the same for the y direction. Notice how for the y vectors, some of the y's will actually cancel, and so mathematically we know that our E in the x direction will move away or move towards 0 much faster than our E and y. And so back at our graph, that will look like our E vector swings down this way as we move away and gets smaller, meaning that these guys will look like 1 point before we go to 0 for our total magnitude.